13.1, question number 1. Two cubes, each of volume 64 centimeter cube. Now you can see two cubes are given to us. Drawing the two cubes. Let the second cube be drawn with a dotted line so that we have an idea that two cubes are joined together. Right. The volume of each of the cube is given to us. Alright, they are joined end to end and then they are laid in the form of a cuboid. Alright, so we have to find the surface area of this cuboid. Surface area. So we find the length, we have no idea about the breadth of it. Okay. Right, so let's begin this sum. First, using the value of volume of cube is equal to a cube. What is the volume of cube? The value is 64. 64 is equal to a cube. Therefore, a is equal to cube root of 64. Now, many of us don't know how to find the cube root of 64. So, we will find it using the LCM method. First, we will find the value of C. Factorize 64. 32, 16, 8, 4, 2, 2. So you can see in pairs of 3 there are two pairs of 3s. So you will write here under root of 2 into 2 into 2. There are 6 2's here. Make pairs out of these. So lastly you get the value of side of it is 2 into 2, which is equal to 4. It means an edge of a cube is of measure 4. Alright, 4 centimeters. Now let's use this measure to find the length. Now length of it, this will give you 4 plus 4. Length is 8 centimeter. The breadth of it will be 4 centimeter. And the height of it will be 4 centimeter. Okay. Now finding the surface area of cuboid. Use the values. Surface area of cuboid is equal to twice in bracket length into breadth plus breadth into height plus height into length. The measurement of length is 8, breadth 4 plus breadth 4 into height 4 plus height 4 into length 8. Solve it. First take all the values inside the bracket and solve them. 32 plus 16 plus 32. Add all these values. So when you add all the values, you get the answer as 80. On multiplying the value, you get the answer as 160 centimeter cube. In the last line, you will get the answer as the surface area of the cuboid is 160 centimeter cube. Now question number 2. Let's read the question. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. So draw the hollow hemisphere first. It is hollow means liquid can be filled inside it. Then draw the cylinder. The hollow cylinder is above it. Let's draw this. Okay. And it's given that the diameter of the hemisphere is 14. Now from here till here, the measurement is given. D is equal to 40. Therefore, radius will be 14 upon 2. Answer will be 7 centimeters. So we can see that this radius of the hemisphere is similar to radius of the cylinder. Alright. Now, we are given that the total height of the vessel is 13. So from here till here, the height of the vessel is 13 centimeter. Hence, the height of the cylinder will be 13, the total height minus the radius. That will give you 6 centimeters. So the height of the cylinder will be 6 centimeters. Now having marked all the values, the measurements of the cylinder as well as the hemisphere, now let's see what is asked to us. They are asking us find the inner surface area of the vessel. Inner surface area of vessel is equal to curved surface area of cylinder. You can see first cylinder and then the hemisphere plus curved surface area of hemisphere. Now the formula to find the curved surface area of cylinder is 2 pi RH and hemisphere it is hollow 2 pi r square. of these values you can take 2 pi common and r common. So we are left with h plus r. 2 pi can be taken common, a single r can be taken common. Alright, as we are not given the value of pi in this, we take the value of pi as 22 by 7. So writing the values, 22 by 7. The radius of it you can see is 7. Height of the cylinder here is 6 plus 7. Solving these values, we get 44 upon 7 into 7. Adding both the values in bracket, you get 30. Cancelling 7, 7 and multiplying both the values, you get the answer as 572 centimeters square. So you write in the last line, the inner area of the vessel is 572 centimeters square. Going to question number 3. Let's read the question. A toy is in the form of a cone. So let's draw the cone first. I'm going to draw both the surfaces using different lines. We are given a cone and the radius of the cone given to us is r is equal to 3.5 centimeter. Right. Next, the total, okay, it is mounted over a hemisphere. So let's draw the hemisphere. So you can see from here, even the radius of hemisphere will be 3.5. We are given here that the total height of the toy is 15.5. Similar to the previous sum, the total height, capital H, is equal to 15.5. So here we can see that only the height of the cone, that is small h, will be 15.5 minus 3.5, minus this measurement. Okay, so the height of it is going to be 12 centimeters. Now we have to find the surface area of the toy, the total surface area. So here we need to combine the surface area of both, and we know that the formula of surface area of a cone is equal to pi r L. Now L stands for the slant height. This L stands for the slant height, but we don't have the measurement of slant height. So what are we going to do? Using Pythagoras Theorem, we will find the value of the slant height. L is equal to under root of x square plus r square. Replacing these alphabets with the values, we get 12 square plus 3.5 whole square. You get the answer as 144 plus, when you multiply 3.5 and 3.5, you get the answer as 12.25. Adding both these values, we get the answer as 156.25. And using the square root by division method, you can solve this value and you get the answer as 12.5 centimeters. So this is the value of slant height. Now we are going to find the total surface area of the toy. So we write the formula as TSA of toy is equal to CSA of cone plus CSA of hemisphere. So formula of CSA, consider cone is pi r L plus pi r square. It should be 2 pi r square. Out of this we take pi and r common. You are left with L plus 2r. As we don't have the value of pi given in question as 3.14, we will take 22 by 7. The value of radius 3.5. Slant height is 12.5 plus 2 into 3.5. So we are left with 22 by 7 into 3.5, and lastly add these, multiply these two, you get 7 plus 12.5, you get the value as 19.5. Okay, and lastly solving, we can solve these two also. Cancel 7 and 3.5, you get the answer as 0.5. You get, then you are left with, on multiplying these two, you get 11 into 19.5. So you will land upon the answer as 214.5 centimeter square. In the last line, don't forget to write the statement that the total surface area of the toy is 214.5 centimeter square. Moving to question number 4. In this, we are given a cuboidal block. So let's draw the cuboidal block first. A cuboidal shaped box is given to us. Okay, it's a cubical block. So all the sides are of equal measure. Write the measurement of this cubical box. The measurement of this cubical box, as we can see here, is 7 cm. So all the measures, length, breadth and height, are equivalent to 7 cm. It is surmounted by a hemisphere. So about this box, we have a hemisphere. I am gonna change the shape of this hemisphere so that we understand that two different solids are above each other. Now as you can see this, the hemisphere is above the cubical box and it is given what is the greatest diameter of the hemisphere. We have to find the diameter of this hemisphere. Actually we know here the greatest diameter can be 7 cm because the biggest hemisphere that can be laid is from here till here. Alright, but we will find it out. We will see what it gives. What is the greatest diameter of the hemisphere that this figure can have, and second, find the surface area of the solid. Now before we find the surface area of solid, we know that when the biggest hemisphere that can be laid is of measure from here till here. So we write here diameter will be 7 cm. Therefore radius of hemisphere will be 7 upon 2. Answer is 3.5 cm. Now we are supposed to find the surface area of the solid. Surface area of complete solid is equal to total surface area of cube plus curved surface area of hemisphere minus, we have to subtract this portion of the base of the hemisphere because it has been embedded between the cubical surface and this surface. We have to remove this area. We cannot see this. Okay, we write area of base of hemisphere. Area of base of hemisphere. Now let's write all the formulas. 6a square for that plus the curved surface area of hemisphere formula is 2 pi r square minus area of base that is equal to a circle that is pi r square. Okay, I suppose we can also solve this value directly here. 2 pi r square minus pi r square, this will give you 2 minus 1 pi r square. Replacing the alphabets with the value 6 into side of cube is 7 into 7 plus 22 upon 7 into radius is 3.5. First to multiply these three values, then solve these three. You can cancel this 7 and 3.5, you get 0.5. Multiply these values and these values, and then so first you get the answer as 294 here on multiplication, and when you solve those values you get the answer as 38.5. Lastly, when you add these values you get the answer as 332.5 centimeter square. So in the last line you will write the answer as, there are two questions in this sub questions. The first answer will be the greatest diameter of the hemisphere will be equivalent to 7 centimeter and the surface area of the solid is equal to 332.5 centimeter. Now question number 5, we have the same kind of sum, but here the values are not provided to us. We don't have specific numeric values in this. We are just given alphabetic values. So let's read the question, understand the concept. A hemispherical depression is cut out from one face of a cubical wooden block. So let's draw a cubical block first. We are given a cubical block. Now from this, a hemispherical depression is cut. we can separately draw the figures and drawing the hemisphere with the help of a dotted line. This is a cubical wooden block. Alright, now what is given to us? We are given that the diameter of the hemisphere is equal to the edge of the cube. It means this hemisphere is lying a distance from here till here. It is this big. So diameter of the cube is provided as L. Therefore, radius will be L upon 2. Now it is given, it is asked, find the surface area of the remaining solid. It means after removing this hemispherical shell from here, we have to find the area of the remaining solid. Now for this I tell you the formula. Area of the remaining solid is equal to total surface area of this cube, okay, then minus the area of the hemispherical depression, alright, plus curved surface area of the hemispherical depression. This will be the formula. First of all, here we will write the formula. Surface area of remaining block is equal to, now let's write from here. The first is total surface area of cube plus curved surface area of hemisphere minus area of hemispherical depression. The formula for total surface area of cube is equal to 6a square. Now formula for curved surface area of hemisphere, the formula is actually 2 pi r square minus the area of the hemispherical depression will be area of circle. This is the area of hemispherical depression, pi r square. Alright, but according to this, now relating to this figure, we have to find the value of radius here. You can see the radius is L upon 2. Okay, and the edge of the block is given as 11, which is equivalent to the diameter of the hemisphere. Now let's try solving this. Can we solve this too? Yes, we can solve this too. You get 6 into L square plus pi r square. Now instead of r, I will write 6 L square plus pi L upon 2, that is equal to radius whole square. This gives you 6 L square plus pi L square upon 4. Okay, taking this LCM, as we take the LCM, you will get the values as 24 L square, because it will be, that's a fraction and this is a whole number. 6 4s are 24 L square. Alright, plus 5 L square upon 4. Right? Now from these values, take 1 by 5. From this last value, you will take 1 upon 4 outside. From these two values, you can take L square common. So if you take these values outside, you see from here, don't cancel them, I am just removing them outside. You will be left with 24 plus 5, and that will be the answer. So in the last line, you will write that the surface area of the remaining solid after we remove this hemispherical shape from here will be equivalent to 1 upon 4 L square in bracket 24 plus 5 centimeter square. Now let's go to question number 6. It is given that already a figure is given to us. A medicine capsule is in the shape of a cylinder. So you can do one thing. Instead of drawing it horizontally, we'll draw it vertically. We'll draw a cylindrical portion of a capsule, and at its two ends we can see two hemispheres. We'll draw them with two different lines. one a dotted line, and it is given that with two hemispheres which are stuck in each of these ends. You can see the figure. The length of the entire capsule is 14 mm. From here till here, the entire capsule's length, capital H, is equal to 14 mm is given to us, and we are given that the diameter of the capsule is 5 mm. Now D is given to us as 5 mm. It means the radius of it will be 5 upon 2, which is equal to 2.5 mm. Now we need to find, as we know that we have two different solids here, two hemispheres and a cylinder. So height of cylinder that we will need for finding the area of it. So total height is 14 minus 2.5. So when you subtract both the values, you get the answer of height of cylinder. Okay, we will not consider it as an h. You can subtract it. So when you subtract it, you get the answer as almost 11.5 mm. So once you get the values, now we are going to find the surface area of the whole capsule. Alright, so finding the surface area of the whole capsule, you get the values as you can write. TSA, total surface area of whole capsule, is equal to, first we need to include the surface area of cylinder, CSA of cylinder. Okay, and including this you can see there are two hemispheres also, so you can write plus 2 into CSA of hemisphere. Now formula for curved surface area of cylinder is 2 pi RH. 2 pi RH plus 2 into 2 pi R square. Now out of these you can take 2 pi R common, because you see measurement of radius is same for the cylinder and the hemisphere. So you take 2 pi and R common, you are left with H plus 2 is left out here and an R is left here. Now in the question we see that the value of the pi is not given as 3.14, so we will take it as 22 upon 7. 2 into 22 upon 7 into radius is 2.5. The height of cylinder is 11.5 plus 2 into 2.5. So what are we going to do? We will solve the values in the bracket first. This will give you almost 5 plus 11.5 is going to give you 16.5. Okay, so solving all the values, you get the answer as 220 millimeter square. So on the last line you are going to write the total surface area or surface area of the capsule is 220 meter square. Let's go to question number 7. In this we are given that a tent is in the shape of a cylinder surmounted by a conical top. We are given a cylinder, it's a tent. Okay, so we will draw the cylindrical portion with a thick line and the conical shape with a dotted line. Now you can see two different shapes, two different figures here. One is a cone and the other is a cylinder. Now what else are we given? If the height and diameter of the cylindrical part are 2.1, the height of the cylinder is given as 2.1 meters and the diameter of the cylindrical part is given as 4 meters. So we can say that the radius of it is 4 upon 2. The answer is 2 meters. So from the value of diameter, we have directly evaluated the value of the radius, and we also given that the slant height of the top is 2.8 meters. The value of L is given to us, 2.8 meters, the slant height of the cone. Now what are we supposed to find? Find the area of the canvas. Now we know that canvas in a tent is always applied outside the tent. So we need to see the curved surface area of it and not the total surface area. Okay. used for making the tent and also find the cost of the canvas. So first we are going to find the total area of the canvas which is used to make the tent, that is including the cone as well as the cylinder. Alright, so let's take the step. Total surface area of tent is equal to curved surface area of cone plus curved surface area of cylinder. Now, writing the values of curved surface area of the cone, the formula for curved surface area of the cone is pi r L, and the value for curved surface cylinder is 2 pi r h. Now, out of these you see the value of radius is common for both the figures. It means we can take pi common from both these and r common. We are left with L plus 2 into h. As the value of pi is not given to us in the question, we are not going to take the value as 3.14. We will take the value as 22 upon 7 into the radius is 2, slant height is 2.8 plus 2 into the height of the cylinder, as you can see, is 2.1. Further solving, we get the value as 22 by 7 into 2 into, let's solve this. Here in bracket you will have 2.8 plus 4.2. Solving the values in the bracket, add them, okay, and lastly when you solve everything up, you get the answer as 44 meter square. So this will be the value of total surface area of the tent. But we also need to find the cost. Find the cost of the canvas of the tent at the rate of rupees 500 per meter square. So in the next line you will write cost of 1 meter square area of canvas is equal to rupees 500. And how much do we need for the tent? We need cost of 44 meters square of canvas is equal to a question mark. So multiply these two values. When you multiply 44 by 500, you get the answer as 22,000. 44 multiplied by 500, which is equal to rupees 22,000. In the last line, you write the statement as, see, you have got two answers out here. So you have two statements here in this answer. First of all, with this, you will write that the area of the canvas used for making the tent is 44 meters